Okay, solving trigonometric equations. This one is a little bit trickier than other ones that we've looked at, so let's take a quick look at this. It says solve sine of 3 theta equals -1 on the interval theta is greater than or equal to 0 and less than or equal to 2 pi. The first thing I'm going to do is look at my unit circle and see when this is true. So it starts off pretty easy. So this is the way I'm kind of looking at this now. I'm looking at this way. I'm saying, when is sine of x equal to -1? And let x equal 3 theta. And I look and I find that this is true for x is equal to 3 pi halves. And that makes sense because if you look at the unit circle, here we are here, and 3 pi halves is down here at 270 degrees, and this has a cosine value of 0 and a sine value of -1. So that makes good sense. From here, though, we have to go back and say, well, we don't actually have x is equal to 3 halves. We have 3 theta is equal to 3 pi halves. And what I really am interested in is what's that theta value? And that theta value is being multiplied by 3. So what I'm going to do is I'm going to divide both sides or multiply both sides by 1/3. And we find out that theta is equal to pi halves. That makes perfect sense because if you plug this back in, if you plug pi halves back in up here, you'd have 3 times pi halves, which is 3 pi halves, which gets you to here. Now, here's the part that gets people stuck, is that this is not the period, this is the interval. The period of this function is accelerated because we have 3 times that theta value. So remember that to find the period of a function, we use 2 pi over omega, right? Or actually absolute omega. So in our case, by filling in, we get 2 pi over 3. This is that omega value right here, right? This is omega over 3. So our period is 2 pi thirds. So we know that sine functions are periodic. So if I keep adding the period to this point, I'll get other values that satisfy this condition. So we would have another theta value, theta sub 2, would be equal to the first one plus 1 period, right? Move over 1 period. And this is what I'm doing. I'm looking at this thing like this thing. If this is the function, if that's 1 period of the function, well, here's another period of the function. And if I take this value right here if I take this value right here, if I go 1 period over, I'll be here, but I'll be at the same value, won't I? So that's what we're doing here by adding this period here. So we'll add 2 pi thirds. So just to do our little bit of math here, I need a common denominator, so I'm going to make this into 3 pi sixths is the same as pi halves, plus 4 pi sixths is the same as 2 pi thirds, right? Is equal to 7 pi sixths. So that's another theta value that works. So here's one, and here's another one. Now I'm trying to figure out, should I continue or not? And the reason I am going to continue is because I'm at 7 pi sixths, which is somewhere in between 0 and 2 pi, but I think that we can get at least one more value out. So I'm going to do a third one. I'm going to do it the same way. Say there's another theta value that we could use, and that would be the second value, 7 pi sixths, plus the period, right? And remember, we have an equivalent for the period is 4 pi sixths, so 4 pi sixths for a total of 11 pi sixths. So that's the third one. I don't think we can get a fourth one because 11 pi sixths is very, very close to 2 pi. And I believe if we added 2 pi thirds to that, we'd go over 2 pi. So I'm going to stop there. All right? Look, I hope this was really, really helpful. This is really difficult stuff. It's not easy, but keep it up. And if you have questions, please make comments. If you haven't already subscribed, please do. Thanks.